Hello everyone. In this video we will be talking about natural base e, natural exponential functions, natural logarithmic functions. We will be using a special number e. So let's talk about what e is first. E is an irrational number like pi. You know what pi is? Pi is a number approximately 3.14. After the decimal point, it goes on forever. Similar to pi, e is also an irrational number whose value is approximately 2.7. After decimal point, the numbers keeps going forever. So this is the special number we will be using in the section e. So we can write our exponential function by using the base e, like e to the x, so which will represent an exponential growth function because our base 2.7 is a number greater than 1, so which express an exponential growth function. Remember how exponential growth functions look like. It's increasing from left to right, slowly at first and then rapidly. So here is how our natural exponential function look like. E to the power of x. It is growing from left to right. It is growing slowly at first and then rapidly. So this is how the function look like. And we also studied logarithmic functions, and we talked how logarithmic functions are inverse of exponential functions. So our natural exponential function also has an inverse function. The inverse function for natural exponential function is natural logarithmic function. We will be using the same base, log base e of x. So remember how logarithmic functions look like. If the base is greater than 1, the logarithmic functions are increasing from left to right like this. Like the red graph here, y-axis is the asymptote, the function is approaching to y-axis and it's rising from left to right, fast at first and then slowly. So these are how natural exponential and natural logarithmic functions look like. And we also talked the domain and range of exponential and logarithmic functions in the previous sections. So it is the same since it is exponential function. E to the x is also an exponential function. Domain and range will be the same. Domain is all real numbers from negative to positive infinity. Range will be from 0 to infinity. And since natural logarithmic function is inverse of natural exponential function, we will reverse the roles of domain and range. So domain of logarithmic function will be range of exponential function. 0 to infinity will be our domain. And range will be the old domain, which is negative to positive infinity. And one more thing we need to know about natural logarithmic function. Just like the common logarithms, remember when we write the logarithm, we use log base b of something. We have a base. And sometimes we don't write the base, we just write the number beside log. So that indicates we have a base which is a 10. So if nothing is written as a base, it is supposed to be 10. So it is called natural logarithm. Just like natural logarithms, common logarithm, natural logarithm, we have e as a base, so we won't be writing e as a base. So this function will be abbreviated as ln x. So the the base will be invisible here. So this is equivalent to ln x. So this is how we express natural logarithmic functions. We are never going to write log base e of x. We will be writing it as ln x. This indicates log base e of x. So let's take a look at some examples and see how we simplify natural logarithmic functions. So the properties of logarithms also apply for natural logarithms, we will be using the same properties. For example, simplify ln e to the power of 3.2. This is the power property. Remember, if there is a power of a number next to the log, we can bring this power in front. Write this as 3.2 times ln e. ln e, ln means log base e. This means log base e, and the number beside ln also e. So we have the same numbers here, log base e of e. Remember the property that we learned in the third section. If the base of the logarithm is same as the number written next to log, then it is equal to 1. They sort of cancel each other. Whenever there is ln and e beside it, then it is going to be 1. E raised to which power is e? It is 1. So I have 3.2 times 1, which is 3.2. We can also say, remember another property that we studied in the previous section. If we have something like that, let's say log base e of e to the power of something. So without even bringing the power in front, we can directly cancel these out and left with the exponent 3.2. So this is the same. You either use the power property and do it in a long way, or you directly cancel ln e and write the power as an answer. Okay, so we have an inverse property in the previous section. A, a base of the exponent is same as the base of the logarithm, and they cancel each other. If we have e to the power of ln x, for example, since ln means log base e, so here the base of the exponent is same as the base of the logarithm, so they sort of cancel out each other. So we will say it's equal to x. So similarly, here we have e and the base of the logarithm is also e. They will cancel each other, but not right away, because we have a coefficient here. First of all, we should remove this coefficient. We have to move it up as an exponent first. So e to the power of ln x squared. Now I can do the cancellation. E, they are same. E and ln will cancel each other. I am left with x squared. Let me clear this, not to confuse. So we use exactly the same properties. So finally, here we see ln e. So as we did in the first question, we can cancel ln and e right away. So when they cancel each other, I am left with the exponent, which is x plus 4y.